back. We're live. We're at ThinkTech, having a ThinkTech Talks today with Mike Deweert. That's Dr. Mike Deweert to you.
Aloha.
Aloha.
Yeah.
Welcome to the show, Mike.
Thank you, Jay. It's good to be here.
Mike is a scientist with BAE Systems. Also, he's a member of the board of the Hawaii Academy of Science, which is to his credit and their credit. And today, well, we had lunch, a couple of weeks ago.
That's true.
I'm so delighted to have you here.
Yeah.
And we were having this creative lunch over a tuna fish sandwich.
Yeah. Right.
And we started talking about the 18th century, and it was so
1700s,
interesting
yeah. Oh, yeah.
that I really had to have more. So we set
okay.
up this show to talk about the 18th century.
Right.
But before we do that, what is a scientist? And what kind of a scientist are you?
Well, debonair, good-looking, and well-dressed, of course. No, a scientist is anybody who studies the laws of nature and via the scientific method, which is hypothesis, evidence, test, new hypothesis, until the process of science isn't so much discovering truth as rejecting falsehood and coming to the closer approximation of the way nature really works. And the kind of science I mostly do nowadays is laser sensing of the ocean. We use lasers to go find things in the water like mines or submarines or the bottom or Moby Dick, whatever somebody wants to find in the water from an airborne platform. We also use lasers to find buried landmines and a lot of things for our Navy customers. So my training, though, my doctorate's in theoretical solid-state physics, superconductivity, and I haven't done any superconductivity now in 20 years. So,
Okay, but then still, you're grounded in physics.
Oh, yeah.
Physics is the highest minded of all the sciences, isn't it?
Well, I'd like to think so, but, as they say, rocket science isn't rocket science anymore.
Okay.
What's going on in biology, biology is physics, but it's physics, describing a biological system with the laws of physics in many ways is like describing a Beethoven symphony in terms of pressure variations. It's a technically accurate way to do it, but it doesn't quite capture, the phenomena you're trying to describe.
Yeah.
So physics is the fundamental basis of all sciences, but there's sciences that are, certainly in medicine and biology, that are almost indescribable purely in terms of what we call physics right now.
When you study science and physics especially, does it change your personality? Does it make you a different kind of, person in dealing with the world and appreciating day-to-day existence?
Oh, sure. I mean, of course, it does spoil movies for you sometimes, because I'll be watching a science fiction movie and I'll say, oh, it's bogus. There's no way they can do that. But sometimes then you think about it and say, oh, maybe that isn't bogus. Maybe it could be done with a technological advance.
Yeah.
But you can look at the blue sky and you appreciate why it's blue. You look at the rainbow, appreciate why the rainbow's there.
Yeah.
What would happen if the laws of physics were a little different, so the next refraction of water was something else than it is, and start thinking about that. Would the rainbow be bigger? Would it be smaller? Would the colors be reversed? That last is almost impossible.
Okay,
but not quite.
Maybe not. Maybe not. I mean, used to think that everything, beyond the realm was impossible, but now fiction becomes fact.
Yeah. For example, our cell phones right now, you look at the old Star Trek TV show from the 60s, and they had these clunky communicators. Well, they looked high-tech then, now they look clunky.
Yeah.
Because we can bounce a signal around the planet now with, you don't even need a cell phone, just have a little thing on your ear that's basically does all that functionality.
Well, it's multidisciplinary, isn't it? I mean, if you're a scientist in physics and you have the method down, which is, as you say, the critical thing, then you can appreciate other sciences as well.
Absolutely.
A scientist in one thing doesn't limit him to that one thing.
Oh, absolutely not. That's the wonderful thing about the modern world. It's interdisciplinary now. Even in almost any effort, you're going to have if you're going to do physics like solid-state physics, you'll need somebody who can do laser physics, you might be working with somebody to do a biological investigation using those tools you're developing. Yes, it's all multidisciplinary. You'll need somebody to do the computer processing, information processing. The mathematical algorithms we now use are just astonishingly advanced compared to what we could do back in the 70s with calculators and slide rules. So.
Well, really, it sounds like being a scientist is tougher than it used to be.
Yes and no. I mean,
the research is easier, I suppose.
Well,
you can find stuff out with global research in a minute.
Right, that's true. In the sense that you can go to the internet, you can type in everything I always wanted to know about copper superconductors, and you get thousands of papers on copper superconductors. Where it gets difficult is winnowing out what's reliable information from what's junk, because there's a lot of junk out there now. And used to be there journals, the reviewers you'd only have a few journals you would read. The reviewers would carefully review the papers, and only ones that pass a certain level would get in. But now anybody can put anything on the internet. And so you have to work a little hard sometimes but that's part of the value of scientific education. You can look at the paper and say, what makes sense in this and what doesn't.
So you're not going to accept every scientific paper?
Oh, no.
Without question.
Right.
You're always going to question.
Yeah, you have to question. You have to question. And that's another thing to learn as a scientist, is to question. That, and you can apply the scientific principle not just to what we consider scientific problems, but to everything. If somebody says, your cat scratched my kid's face, you can say, well, I know my cat was locked in the basement at that time, and look for evidence. You can look for evidence for things. Or like in the legal profession, there's this thing called the Prosecutors Fallacy, where they'll take a blood sample and say, this blood type is only 6 people in 1,000 have it. You have this blood type, therefore there's only a 6 in 1,000 chance that you weren't the culprit. That's the Prosecutors Fallacy, because in Honolulu, if there's a 6 in 1,000 chance, that means in a population of 1 million people, there's 6 times 6,000 people who could have done it, in principle, just on the blood evidence. And so you can start asking these questions like, is this evidence really sufficient to convict, or sufficient to spend money on if it's a case where you're like looking at somebody else?
But sometimes those are sometimes pretty subjective tests, but they're sort of based on some good experience, right? And you get to refine your subjective judgment on things. Right.
You learn to ask what the assumptions are that went into the calculation, then you can refine your judgment. And sometimes, of course, you still just have to go with incomplete information. There's a whole science about how to make decisions with incomplete information.
Hunch, on the basis of hunch. So scientists, just like policemen, use hunches, is that it?
Well, you can use hunches, but you're also supposed to use evidence. And follow the evidence.
Well, I was thinking about, the other professions. I'm not sure you could say scientist is a profession. Maybe it is. It's more than a profession somehow.
Vocation. Yeah.
Okay, but if you're a doctor, you're going to be reading medical journals.
Oh yeah, absolutely.
And if you're a lawyer, you could be reading cases and events that take place, in law. But it seems to me that it's even more important that a scientist in a given area, whether you're trained in the area or working in the area, you have an interest in the area, you must stay current.
Yeah.
You can't not stay current. So what do you do to stay current?
Well, going to conferences helps because you get to talk to people who are doing exciting stuff. Working, in a place that has to make a profit helps because you're going to go out and do the research to make sure that you are current, that you're ahead of your competitors. You read journals, go to conferences. Sometimes you just call up a colleague and say, I saw this thing, I don't understand it, have you heard about it? And they'll say, oh yeah, this is blah, 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 blah. I saw this in the Croatian Journal of Underwater Archaeology, or something.
Okay.
So, right. It's hard to stay current, when you're in a multidisciplinary area, like I am, where we have to do oceanography, we have to do lasers, we have to do cameras. It's hard to stay current on all the technology. So you do have to rely on your team members staying current too. And that's a challenge, keeping everybody current while they're working like crazy to get a task accomplished.
Oh, let's talk about the team. Team. Yeah. So scientists work in teams now. It's not the mad scientist in the attic anymore, like Frankenstein, young Frankenstein.
Yeah, that's an incredible luxury if you are in one of those fields where you can be the mad scientist. But
what was his name? Tesla.
Nikola
Tesla.
A brilliant individual.
What a brilliant guy. Yeah. He worked by himself mostly.
Yeah, and he worked by himself a lot, and maybe that's why he wasn't as successful financially as Edison. Edison, we know, invented the telephone, invented the phonograph, he invented the battery for submarines, an alkaline battery that had the advantage of not setting off sparks that would explode in a confined space.
This is very important.
Yeah, so Edison invented a whole bunch of things, but the most important thing he invented was the modern research laboratory. he invented a way to systematically get a team of multiple disciplines together to solve a problem and advance something with the goal of making a profit, but it made a systematic way to do that. That may be his greatest contribution to technology.
Yeah, interesting. So the method and the method of teaming up.
Right.
You know, I spent some time recently with Kevin Hughes. He's one of our long-term friends and supporters. And Kevin got involved with a company called InMobi, which is in India. And he has been here in the Manoa Innovation Center. And when they want to do something, they do a global conference. I love that. You know?
Oh, yeah.
So they have all these talent, these very talented people, information technology people, all over the world on the phone or whatever, you know, or chat at the same moment around the globe.
Oh, yeah.
And you get a tremendous product that way, don't you, when you do that?
It certainly makes it easier than having to go visit your colleagues or do what they had to do in Einstein's time, write letters back and forth. So Einstein would write to Curie, and she would write back, and it would take time. So now you can do that collaboration much more quickly with people all over the world. You know, makes it easier, but that means that everybody else can do it too.
Yeah.
So the amount of information is just growing exponentially with time right now. And now eventually that will turn over because the population is finite, but it's still growing way faster than we can keep up with. So.
Just a sidebar on this. We will get to the topic of the 18th century pretty soon, but when you talk about Madame Curie and all that, I remember, I can't remember the names right now, but there were a couple of guys around her that stole her stuff on DNA, wasn't it?
No, that was Rosalind.
Rosalind.
Oh dear.
Okay.
Yeah, but the lady, the Watson and Crick worked with this brilliant researcher. Unfortunately, she died of cancer before the Nobel Prize Committee could consider the work. But she made some major contributions to the discovery of the double helix in DNA, for which she until recently didn't get a lot of credit. And this could be because she was a woman. Okay? And this happened a lot to women back in the 30s. Like, for example, Maria Goeppert-Meyer, brilliant astronomer, got very little credit. Lisa Meitner worked in Germany with Otto Hahn. She discovered nuclear fission. She was the first person to propose that they had these weird observations, this weird radiation comes from certain ores of uranium. They didn't understand it. Lisa Meitner proposed, think this is an atom splitting and releasing a few neutrons into big fragments. She basically discovered nuclear fission. Otto Hahn took credit for it. The Nazis came to power. She was a Jew and a woman. She had to flee for her life. Otto Hahn gets credit for discovering nuclear fission. We named an element after him, hahnium. And then later on it comes out, when they went and looked at the old Nazi documents, that he had just stolen all the work. His Nobel Prize was taken away from him. Now, unfortunately, Lisa Meitner was dead, and you don't award Nobel Prizes to dead people. But they renamed the element hanium Meitnerium.
Oh, how interesting. Good for them.
Yeah, so this happened a lot to women back then. Maybe it still does. It's an injustice that when we find it, we should try to rectify it. Like now we have Meitnerium instead of hanium, and Lisa Meitner is now recognized as one of the most brilliant scientists of her time.
Well, it goes to the question of selecting the members of your team. Yeah. And I guess the question I would put to you is the principal investigator who runs the team, whether it's a formal or informal team. You know, I mean, it doesn't have to be. You don't have to be the formal principal investigator to create a team. You can just create a team.
True. You can create a team.
But how do you protect yourself from the likes of Crick and Watson, who would take the intellectual property away?
Well, you can. Yeah, that's a hard question.
People carefully.
Yeah, you do have to be careful who you select. I mean, we see this not just in science, but we've seen it in we've seen it in the computer industry where people will take credit for somebody else's invention. There's all these movies out recently about certain software companies and people saying I deserve credit for that, and they didn't get it. And there's people who copy really good ideas without attribution and get credit for it. You can publish, that's one way. If you're in the defense industry, you're not allowed to publish much. You can patent, that's another way. But then the problem with a patent is now it's public. You've got to disclose enough when you write a patent that somebody skilled in the art could reproduce your work.
Patents are public.
And patents are made public. So, so basically you just have to be really careful who you work with and who you talk to.
I guess that applies across the board in terms of all humanity.
Yeah. You gotta, it's odd as a scientist to say you have to be a good judge of people.
Yeah.
But you do. So.
They say that real estate isn't about real estate, it's about relationships.
Yeah.
Well, science is about relationships too.
In many ways it is. In many ways it is.
We can take a break, Michael.
Okay.
That's Mike Deweert. He's our chief scientist here at ThinkTech, which we are honored to have him as our chief scientist. He gives us legitimacy. Thank you for that, Mike. So he's with BAE and the Hawaii Academy of Science. This is ThinkTech Talks, where we will talk about the 18th century and how it had high tech too. We'll be right back.
Aloha, I'm Nicole Horry for ThinkTech. For nearly half a century, the Hawaii Foreign Trade Zone No. 9 has brought the benefits of the Foreign Trade Zone program to Hawaii businesses and entrepreneurs. DBET, the Department of Business, Economic Development and Tourism, operates Hawaii's Foreign Trade Zone program to encourage international business and economic development. The Foreign Trade Zone's mission is to increase the amount of international trading activity in Hawaii, thereby providing employment opportunities for the residents of our island state. For more information, see ftz9.org. I'm Nicole Horry. Mahalo.
Okay, we're back. We're live. In case you're wondering who the gentleman next to me is, that's Mike Deweert, ThinkTech's chief scientist. He's with BAE Systems and the Hawaii Academy of Science. So Mike, what about these journals? You know, hear about the journal Science, the journal Nature.
Sure.
There must be half a dozen of them that come to mind.
Sure.
What do you like?
Well, when I publish, it's usually in the SPIE, the Society of Photo-Optic Instrumentation Engineers Optical Engineering Journal. This is very technical. When I like to read, just to try to keep up on what's going on in general, just things like Science News and Scientific American. Oddly enough, Business Week has some good technology articles sometimes in it. You really get a flavor for how fast things are moving. I want to get that from you. You know, when we went to school, I wasn't in science, but I liked it. And when you went to school, things moved at a certain pace. Right.
But now with the internet, it must be different.
It is very different. There's no way an individual scientist can keep up with everything, even in his or her own field. I couldn't keep up with everything in ocean optics. There's just too much going on.
Wow.
So you just try to keep up with things related to your problem right now. So I have a colleague in Sweden, Dr. Katarina Schwamberg, a cancer researcher, and she says if you're looking for water, you're going to have to dig a well 60 feet deep instead of 6 wells 10 feet deep. You're better off focusing on one problem in depth for a finite time perhaps, but focus on it in depth, learn everything you can, and then move on to the next one.
It's a metaphor.
It's a metaphor. Okay. Yeah, it's a metaphor. You have to dig really deeply to make progress. I had another colleague, whose name unfortunately I can't remember right now, who said the first thing you should do when you go into a new scientific field is look at the basic assumptions of the field and see where fiddling with one could give you a way to make progress that somebody else hasn't thought about. Because there are certain people in certain fields who say, this is the way we've done it, this is the way we've always done it, this
dangerous
is our assumption.
Thinking.
It can be dangerous thinking. I mean, for example, there was a famous theory in information theory about Shannon's sampling theorem, how fast you have to sample a signal. And there's something called the Shannon Limit, which says how well you can transmit information that's been sampled. And it took from the 1950s when Shannon proposed this theorem about information transmittal. People wrote doctoral dissertations. They tried to get 5% closer. Nobody came within a factor of 2 of Shannon's limit for 50 years. Then some French engineers just thought about, let's do some let's connect 2 transmitters together so they cross-check each other. And bang, they were within 2% of Shannon's limit right away. And everybody is poo-pooing, all these just engineers. I don't know what they're doing. They've made a mistake, clearly. But people checked it, and by golly, they were right. And all of a sudden, 50 years of doctoral dissertations go in the trash, And we're now within a fraction of a percent of the theoretical best possible transmission of information we can get. And
Okay.
it's standard technology now on your cell
Shows
phones.
you're going to keep
yeah.
an open mind.
Yeah, yeah.
I mean, it's all about methodology of thinking.
Yeah.
But you know,
And I'm summarizing the technology very broadly.
we hope so. We only have a certain amount of time here.
Right.
But again, as always, we want you to talk at your level of science. And one thing that strikes me is that not all the scientists in the world are in this country.
No, that's true.
You've been mentioning scientists everywhere. Throwing off names of countries that don't get in the news much. And it sounds like science has become a global experience in our time.
Yeah, I mean, we are a little. When I was a kid, we were a little arrogant in the United States because we had all the best scientists in the world, and for a time we did. I mean, all the European scientists had fled. The World War II had decimated, scientific enterprise in Japan and throughout much of Asia. Britain had brilliant scientists. A lot of them had fled from Europe, but we were the biggest player on the block by far. Then the Soviets came along and stunned us with Sputnik, but we were still a little arrogant. I mean, for example, when I was studying superconductivity, it turned out there was this whole school of Russians doing it at the same time. Nobody in the United States knew what they were doing. And when we finally started talking, we found, oh my goodness, this is a fundamental new insight into how these things work, how these superconductors work. And we had been totally ignorant of it. And now with modern communications, that kind of ignorance wouldn't go on long. And we're appreciating that, the Italians, the Argentinians, the Brazilians, the Chinese, the Indians, everybody are doing amazing work now. And you can collaborate, people all over the world, and be up to date, on the current technology, the current science.
But once you're a scientist, I mean, are you assured of having a good life? Or can you find scientists who are homeless?
You can find scientists who are homeless.
What happens? I mean, what kind of an occupation is it? If I have a job, you're going to do better.
Yeah, on average you'll do better because you got a higher level of education, you've got a skill.
Yeah.
But scientists are people. Sometimes, I met scientists that just lost their taste for science. They wouldn't do something else, real estate, whatever. And misfortune happens. People get sick. The number one reason for people to file bankruptcy in the United States, well, not maybe the number one, but one of the top reasons is illness. And you can end up going from, medical bills can bankrupt you. You can end up on the street. And your PhD won't help you much if you can't work because you're sick.
Yeah.
Mental illness happens to people. Schizophrenia, it's a biochemical process, and being a scientist doesn't necessarily protect you from having that happen. Alzheimer's. You might understand what's going on better because you're a scientist. You might be able to understand when you're lucid, the state of the research, but right now we can't stop it, the progress of Alzheimer's. And that's something although I did see a very interesting talk night before last at the Science Cafe.
That's part of the Academy of Science.
There's some very interesting research going on at Queens now on taking old drugs and repurposing them for new purposes. And they think they found a new use for an old compound that can actually make brain plaques due to Alzheimer's much more visible at a much earlier stage, amongst other things. And I don't want to talk too much about it because they're filing patents on it and they're negotiating with drug companies and stuff, but they found that they may be able to make it much, much easier to see where the lesions are happening so you can diagnose earlier. Maybe if you can diagnose earlier, you might be able to intervene earlier. And that's to be hoped for. There's progress coming.
Ooh, so, exciting.
Yeah,
Ooh.
yeah.
Okay, let's go to our luncheon conversation.
Okay.
So we don't run out of time on it.
All right, sure.
So the proposition at our luncheon was, the people in the 18th century had high tech too.
Oh, sure.
In their time, and in fact, we should admire them for that.
Oh, yeah.
They were ahead in many ways of where we are now. The average Joe. Anyway.
The average person.
Why don't you state the proposition?
we are a technological species. The reason for our dominance on this planet is because of our technology. And technology, anything from a spear point to a cell phone to a rocket. In the 18th century, well, there was sailing ships, both the European ones and the Polynesian ones, and in the Indian Ocean, the Arab ones. I mean, that was the Chinese had a totally different sailing technology. Well, not totally different, but very different. It was more like our modern airplane wing kind of airfoils. Instead of kind of push along, and kind of you orient to the wind, and the wind creates lift along it. So we have sailing technology was all over the world, and it was a very high-tech endeavor. I mean, a sailing ship has thousands of parts, especially the larger British, frigates and the American clipper ships. And it took a lot of hard work by a lot of people over, and an infrastructure was built up over 1,000 years: docks, timber, how to make pulleys, how to do everything, and then the navigation technology. I mean, without GPS, how would you get from one side of the ocean to the other and get where you wanted to go? The Polynesians, the Europeans, they navigated by the stars. The Arabs invented something called the Astrolabe, which became a sextant that let you take accurate readings of the angle of the stars or sun relative to the horizon. And if you'd observed the stars, you could say how far north you were easily. If you were able to take multiple simultaneous measurements of the stars, the British found you could see how far west you were, as long as you knew you weren't moving. And so even before the invention of the clock, which is almost universally regarded as something that was a clock that you could take to the ocean, not a pendulum clock, that made navigation, finding how far west you were, a lot easier. But the British had figured it out that if you take multiple star sightings simultaneously, and you have charts of where stars are in various parts of the sky, you could also figure how far west you were. That's why when the British charted the Hawaiian Islands, their charts are accurate. The Spanish had also stumbled upon the Hawaiian Islands. They didn't have this technology of calculating from simultaneous star measurements how far west they were. They were hundreds of miles off. The Hawaiian Islands they had were way east of where they really were. That's why they never found them again. Well, so
it's maybe happy for us, yeah.
Perhaps. I don't know.
Perhaps.
I don't know, Spanish is a fine language. I lived in Tucson for 6 years. I really enjoyed it there.
Okay.
But it's just one of those accidents of history that the British invented technology for accurately determining where they were in both latitude and longitude before this is not supposed to be going on.
Okay. Well, it's okay. You want to put them on the air?
No. I thought I turned it off, Jay. Sorry about that.
No problem. So, it strikes me that if the Spanish knew that the British had this high-tech navigation system, they would want it. And it was probably classified in some way by the Admiralty, no?
I don't know. Yeah. It's funny. It was a very laborious way to do it before ocean-going clock was invented. This was a very laborious way to do it, very hard to teach, and took real discipline to use. And the British were famous for their military discipline in the Navy. Just having to do a sail drill where you had to go aloft, unfurl the sails as if you were in combat, that took an incredible amount of discipline, and it was incredibly dangerous. The Admiralty, whenever they had to do a sail drill at sea, the Admiral would tell the captains, okay, tell me how long it took you and tell me how many casualties you had.
Ooh.
Because they wanted to do as fast as possible. They didn't want to lose a lot of sailors either. So both metrics were important. But this whole technology of organizing a group of people to do this sailing endeavor that's a technology too, social organization. We may not appreciate it, but it's really made us a dominant species. Our ability to socially organize ourselves to accomplish more than a band of 5 hunters and gatherers could do together.
Yeah.
So
this is so interesting. And this is at a time before the Industrial Revolution.
Oh, yeah.
This is at a time when, if you look around in society for the elements of high tech, you find a lot of it focused at sea.
Oh, yeah.
At sea. That's where they were putting their effort. Yeah. And it meant economics, it meant military power, and it meant the ability to do everything around the world, and they did.
Right.
Because they had this technology.
It was, the British could project power all over the world because they had mastered the sail. Now, they had to master it. because they're an island country.
Yeah.
And just like the Venetians had to master it, earlier, they were an island country. And for a while, Venice was the master of the Mediterranean, and because of their sailing technology. So,
Okay, well, we now we've set the stage.
okay.
We're going to go into other kinds of technologies
Sure.
that existed. We can try to examine life on the street in the 18th century
Oh, wow.
and see how well our people on the street, I mean everybody,
Sure.
could do in the 18th century. Or put it this way, without the technology we have today, would we be able to return to the high tech of the 18th century? That was the proposition.
Yeah, that's the idea. If civilization collapsed tomorrow, well,
Yeah.
it could well be Amish.
Yeah.
That'd be hard.
they'd be in good shape.
They might be in good shape, but they still have to get steel somewhere.
Yeah.
And they use steel saws, they use steel tools, and could you smelt iron into steel?
That's the question.
Yeah, that's the hard question. Now, in the Pacific Islands of Polynesia, there's a much metal. I mean, our rocks are basaltic. There's not much iron, copper, any kind of metal deposits. So we would have to reclaim the iron from our trash heaps, essentially.
It's out of Mad Max at Thunderdome.
Yeah.
We'll be right back.
Okay.
We're going to take a short break. This is Mike Deweert. He's our ThinkTech chief scientist. He's also a scientist with BAE Systems and the Hawaii Academy of Science. We're talking about the 18th century and the fact that they had high tech then too. And we are examining that. We'll be right back after this break.
I'm Bill Spencer, president of the Hawaii Venture Capital Association. We do monthly luncheon programs with ThinkTech about things that matter to Hawaii entrepreneurs, investors, and business service providers. So join us on the fourth Thursday of every month at the Plaza Club. For information about upcoming events or to join our mailing list, visit hvca.org. See you there.
We're back. We're live. I'm Jay Fidell. This is ThinkTech Talks with Mike Deweert of BAE Systems. He's a scientist and he's a member of the Hawaii Academy of Science. And today we're sort of examining what it is to be a scientist, but we're also looking at what a scientist thinks of the 18th century. Because, it's not just primitive. It's not just way back when.
Yeah.
It had a lot of class.
Yeah. That was a time of Isaac Newton, well, actually a little after Newton's time, brilliant scientists back then, as well as brilliant everybody. Mozart lived in the 18th century, and violins are a big technology. Piano was a new technology then. And they had a lot of construction technology as well. There was things that they had built up a huge infrastructure to do that we may not appreciate.
Yeah. The focus was different, but the effort and the thinking and the creative product was terrific.
Sure, absolutely. And just sheer difficulty of living back in the 1800s, so before the Industrial Revolution, before we had started pumping on oil out of the ground, before England had really appreciated the value of the coal deposits they had. England before the 18th century was sitting on an amount of energy equivalent to all the oil in Kuwait in the form of coal in Wales, and that fueled the Industrial Revolution. The 18th century was right before the Industrial Revolution. We were still doing things with horses, carriages, sailing ships. It was just a much more difficult life than we have.
Mm-hmm.
For example, they could make steel. A lot of civilizations around the world had mastered making steel, and yet they didn't waste steel. It wasn't used in everything. Like we have inner spring mattresses in our homes. We don't think anything of it. They didn't waste steel making springs to sleep on. So what they did have for the bed comfort, for example, was you can go to Trenton, New Jersey, and see this in some of the old exhibits from the Revolutionary War. They would have a mattress, and instead of springs, they'd have a grid of ropes under the mattress, and the ropes would hold the mattress up and provide some springiness so it was comfortable. But the ropes would sag with time and humidity. So what they had was a little lever that you would twist, and it would tighten the ropes. So the phrase "sleep tight" comes from that.
Come to ThinkTech and you find stuff like that. That's a real piece.
Yeah, it's an amazing solution to a problem of everyday comfort, to make your everyday life easier in a time when it was really hard.
Well,
Farming was hard. You had to have hundreds of people to do what we have 3 people to do now. For
but you
example.
got it done.
Yeah, but
There were systems.
Yes.
Humanity was organized, and you could actually do agriculture
Yeah.
in those days.
Yeah.
I just want to say that part of this is a huge spirit of innovation.
Oh yeah.
It's innovation because you absolutely needed to have innovation.
Yeah. And we wouldn't survive without technology.
Yeah.
So,
At any point. I mean, civilization is technology.
Making fire is a technology.
The first one.
Yeah.
And I always like to think that the first really leveraged technology was what? The dog.
The dog, absolutely.
Train the
one of our
dog to do
greatest
stuff.
inventions. Turning wolves into dogs. I mean, an amazing endeavor over thousands of years by humans. Maybe they didn't have the earlier hunters who were domesticated animals probably didn't have the Chihuahua in mind.
No.
They probably had, something else, something to help them bring down, the elk. That's what they had in mind.
Right.
Dogs are one of those things, though. It turned out that when you look at the dog genome, of all the mammals, they have the greatest variety of sizes. You look at smallest Chihuahua, the biggest Great Dane, huge variety of sizes. These animals can be turned into almost any kind of hunter. You can make a dachshund that'll tunnel into the ground and go after the badgers. You can make a rat terrier, go after rats.
And we bred them. This wasn't accidental. This was technology to breed them. We were learning Mendelian, hybrid. What do you call it?
The dogs are our greatest invention, perhaps.
Yeah.
So
So let's go to concrete now.
Oh well.
Because concrete takes us to where we need to go to make the comparison. Between then and now.
Yeah. So the Romans invented concrete actually back in before the Roman Empire fell. And what you do to make concrete is you take limestone, and you could take coral lime, which we used to do here in Hawaii. And you take the limestone, you crush it up, and you put it in an oven. And the oven you stuff with charcoal or coal. You want carbon. And then you seal it airtight, and you heat it from the outside. And what happens is the carbon in the coal or charcoal volatilizes, and carbon's looking for something to combine with, and it looks for oxygen. It turns out that the calcium carbonate in the limestone, the oxygen likes carbon better than it likes calcium. And so the carbon will suck the oxygen out of the calcium carbonate. You get carbon dioxide now, and what's called quicklime. Quicklime now you can crush it up, use it as a powder. It's what's in your bag of concrete, your bag of cement. And if you combine it with oxygen again, it becomes stone again. But it doesn't do it very quickly on its own. You have to mix it with water to accelerate the process. And the Romans had discovered this. They had discovered
incredible discovery.
Amazing.
Trial and error must have been going on for a while before they figured this out.
Yeah, I mean, somebody just had a fire that they'd accidentally had an anaerobic condition under the fire pit, and they pulled they pulled something out of the hearth that was this quicklime, and they probably didn't know what it was at first, but they figured out eventually how to do it.
Changed the world.
Yeah. Some of those Roman concrete structures are still in use. There's Roman roads that are still in use. And the Romans, they found that they didn't use reinforcing rods. They had to make the concrete strong. So what they would do is
Unfortunately, we don't do that. we should take a page out of their book. Make strong concrete.
Well, yeah. What they do is they found that if you used a very little water and packed it tight very laboriously, you could make something that was really dense, really durable, would last a long time. We take shortcuts. We found the problem with putting steel reinforcing rods in concrete, though, is it makes the concrete very strong in both tension and compression. It won't break when you try to bend it as much. But once those steel rods start to rust, they expand and break the concrete from the inside. And so
the Romans didn't have that problem.
The Romans didn't have that problem. I mean, they had other problems. They had to make all their structures compression structures, because concrete is very strong in compression. You can put a lot of weight on it and stack it up. But in tension, if you try to torque it, it could crack, it could break. That's why stone buildings without steel were limited to about 10 stories, because the wind loading would cause them to start to twist, and you'd put the wall into tension instead of compression, and it could break.
So did concrete, go through the Dark Ages and the Middle Ages? I mean, or was it lost for a time and rediscovered?
That I don't know.
It's an interesting
It's
thought.
an interesting question. I meant to look that up because I thought of that too. I thought, why don't I see much about concrete in 18th century in America? Why do I see cobblestone roads, not concrete roads?
Sounds
Why do I
like it
see
was
brick buildings, not concrete buildings?
Yeah. We're going to take a break again.
Okay.
I don't know why. Maybe if we take a break, we can remember about seeing the concrete with the cobblestones.
Right, could be.
Yeah, in your mind's eye. In your mind's eye, that's Mike Deweert.
Yeah.
He's a scientist with BAE Systems. He's also ThinkTech's chief scientist, and he's with the Hawaii Academy of Science. I hope we have time to talk about that just a little bit. And we're talking about the 18th century and how the 18th century had high tech too. And we'll be right back after this break. Aloha, this is Jay Fidell. ThinkTech and the Hawaii Venture Capital Association put on monthly luncheon panel programs at the Plaza Club here in Pioneer Plaza. Our program this time is on September 26th. It's called Solar in Hawaii. We're going to examine the solar industry and see what's in it for the long haul. We have a great panel, great moderator. We'll be sending out email on this. If you want to be in our email list to receive the details, check out thinktechhawaii.com. In any event, you can sign up for the program at hvca.org. Thanks. See you there. This is Jay Fidell. Mahalo. This is ThinkTech. This is Jay Fidell. I'm here with Mike Deweert, as a scientist with BAE Systems and the Hawaii Academy of Science. We're talking about the 18th century. And in the break, Mike came out with a tremendous nugget, is that, we are good at energy.
Oh, yeah.
We have been studying energy. I mean, the Romans, everyone has always started from the time of the clan of the bear cave.
So to speak.
We know about energy. It's just that we haven't been studying the right kind of energy, and that's the challenge today.
Yeah.
Anyway, okay. So going back to concrete.
Okay.
And I use it as an example of trying to figure out why the 18th century, of all the centuries, is so important in making the comparison with the 21st century, just 300 years later. And it's because of this scenario, the scenario of you wake up one morning and we don't have modern technology.
Right.
We don't have our cell phones. We don't have a lot of electricity. We're missing all that. We're thrust into the state of nature of the 18th century. How well would we do?
Ooh. Well, the 18th century had hundreds of years of infrastructure built up. That when you talk about sailing ships, you need technology with the timber, you need to select the trees right. They actually planted groves of trees and trained them into the shapes they needed for the ship timbers in England. And that was centuries of foresight.
Yeah.
They would plant. They would build when they built a new college in England. They called it the New College. I can't remember, that's Oxford or Cambridge. And they planted a grove at the same time of trees that wouldn't be ready to harvest for 200 years because that's when they figured the timbers would be rotted and needed to be replaced. It took foresight and planning back then.
Scientific thinking.
They had to think ahead, and they did think ahead. You look at the technology of farming in England or Switzerland or even New Guinea. It's all these terraces and hillsides that have been made over centuries to capture water, to be fertile, systematically made to support farming before there was industrial technology and tractors and stuff. Here in Hawaii, the ancient Hawaiians, they had to build irrigation canals, irrigation systems that didn't rely on mechanical pumps. And they had whole systems of terraces, they had kalo farms, that it would take us centuries to feed the million people they used to feed. The population of Hawaii before Captain Cook came was close to 1 million people by some accounts. And they had a whole technology infrastructure of agriculture built up to support that.
How could we do that again? Because we are spoiled.
We are spoiled.
We have been living, easily. The average person has no idea how to make concrete or to do agriculture.
Right.
It's a special thing. And, it really makes you appreciate what they were doing, how far they had come in the 18th century.
Yeah.
Not only in the U.S., but even
everywhere.
Think about Machu Picchu.
Oh, yeah.
They had some really good agricultural and hydraulic technology going on.
Oh yeah, all that technology for building stone buildings. And the Aztecs, the Incas, those people were doing it with stone tools. They didn't have iron. They had copper and gold. They didn't even have bronze, though.
So the big question, Mike, the overarching question is, do we have, as a people, as a civilization, a world civilization, the ability to generate that kind of innovation again? Or have we gotten soft?
Well, in some ways we've gotten soft, but there's plenty of very, very smart people all over the world that are still hungry. I hate to say it, if civilization were to collapse for some reason tomorrow, or next week, we would be a much smaller population within months.
That means people die.
People would die. People would die. Perhaps without modern industrial technology, the world could support maybe 1 billion people. I think it could support more, perhaps, but 1 billion people is about what you could do sustainably on the planet without that modern technology, without oil or nuclear energy or some other industrial technology. But there's no reason for civilization to collapse on us.
No, there isn't.
That is a choice.
There isn't, but it's provocative to think about Mad Max at Thunderdome.
Oh yeah.
Using all the the leftovers from the previous civilization and trying to recreate a civilization. And it just so happens that a couple of nights ago, late night TV, there it was, Mad Max at Thunderdome.
Oh yeah,
one of my all-time favorite movies.
And the scientist, trying to engineer pig waste into methane, and it's not. It's not crap. It's energy. Right. So but that's the kind of thing you could try to do. You could try to do. But that would be that Mad Max, I think, is both pessimistic and optimistic. It's pessimistic in the sense that it postulates a total collapse of world civilization. It's optimistic in the thought that you could actually successfully mine the old civilization to run any kind of semblance of a society, and that's pretty optimistic.
So it's really a question of scale, maybe. Living now, being a scientist, you'd have great gratification in doing hyperspectral imaging, if you like.
Sure, we've done that.
And the guys who used concrete and made roads and maybe understood about putting steel in the concrete back in the 18th century, they had great gratification too.
Right.
Innovation equals gratification, doesn't it?
It does. You get a real sense of satisfaction for having invented something, having discovered something nobody's known before. And the scientific method is perhaps the greatest legacy of the 18th century. In the year 1800, the end of the 18th century, you look at the European states, Britain, you look at China, you look at Turkey, they're all pretty much equal. By the year 1900, there was no comparison. It's because Europe latched onto the scientific method in a systematic way of hypothesis, test, new hypothesis, reject what's not true, go on, and keep progressing systematically. In a century, they had taken leaps and bounds progress over everyone else who had not yet realized the power of the scientific method. And that is probably the 18th century's greatest invention and the greatest legacy to us on our planet. That we have now a method that if civilization were to collapse tomorrow, it could still go back, apply the principles of science to find out how to work with what we had and start making a better civilization again. It would take a long time.
Back to Williamsburg, Virginia, colonial days.
Yeah. Jefferson.
Well, we're not finished.
Okay.
We got lots to go. You'll have to come back, Mike.
Okay, I will.
All right, that was a great discussion. Thank you for elucidating me and everyone on all those things.
Thank you.
Clarity.
Anyway.
That's Mike Deweert, BAE Systems, a scientist, and with the Hawaii Academy of Science. Next time we'll talk more about that. And today we talked about the 18th century and how it had its high tech too here on ThinkTech Talks. We'll be back later with Asia in Review. Just give us about 10 minutes and you can watch that too. Thank you, Mike.
Thank you, Jay. Thank you. Aloha.